So I'm really very happy to introduce you to our next speaker, David Chandler. David has a Bachelor of Science in Physics from Harvey Mudd College. He has a Master's in Arts in Education from Claremont Graduate University, a Master's of Science in Mathematics from California Polytechnic University. He is coordinator of 9/11 studies, and he's retired from 35 years of teaching physics, mathematics, astronomy at the high school level and in junior college level. He has been active in 9/11 research since 2006. So today, David will summarize multiple lines of evidence for a large plane approach to the Pentagon. This includes the near-perfect alignment of the damage path, the radar path, the flight data recorder path, and the majority of eyewitness testimony. He will conclude with an examination of the photographic evidence of a large plane approaching the Pentagon in his film, Seeing the Plane at the Pentagon. Thank you. Welcome, David Chandler.
Okay, the next two talks, actually, mine and Wayne's, we're going to be talking about mostly the physical evidence right at the Pentagon scene. We divided it up. I'm taking the approach to the Pentagon, and Wayne will take it into the collision and the debris and so forth. So, for me, the clearest indication that a large plane approached the Pentagon on 9/11 is not any single piece of evidence, but the alignment of many pieces of evidence of different kinds. It's the interconnectedness and cumulative nature of the evidence that strengthens the case as a whole. This is the comparison of the radar data and the FDR data for the flight of AA-77 as a whole, from takeoff at Dulles to its termination at the Pentagon. Some have pointed to gaps or mismatches in the radar record that might allow room for a plane swap mid-flight, but the fact that the FDR records a single plane from start to finish would seem to rule out a swap. Here's the final leg showing the radar and FDR data as the plane comes around to the final approach to the Pentagon. The Pentagon is here in the top right corner. The diamonds are individual radar points. They're color-coded. There's 4 different radar stations taking this data. The yellow line is the FDR data. And this diagram was shown to me by Frank Legg when we were working together on a paper. And this diagram is what first really got me off the fence and realized that there was very strong evidence for a plane approaching the Pentagon. Here's a zoomed-in view. The radar data ends right here, right near the Sheraton Hotel. This is the Navy Annex. Up here is the Pentagon. These red marks around the FDR path are the light pole damage, and so we see the alignment again. The color-coded dots inside the building is the damage to individual columns, and over here the red indicates missing, various others are stripped or bowed, and so forth. So you can see that the path of the damage internal to the building, and these yellow dots are the light poles that were knocked down, and then the other light poles that were not knocked down. So you can say these are go and no-go, kind of a little bit about the span of the wings just from that. I mentioned that the FDR leads all the way to the Pentagon. This needs a little more explanation. If the government had fabricated a propaganda version of the FDR data to sell us on an official story of a plane that didn't really exist, that's what they would have shown. What we have instead is an FDR file where the second to last frame is corrupted and the last frame is unreadable by normal methods. And by the way, each frame holds 4 seconds of data. So all of the data approaching the final approach to the Pentagon is problematic. It took the Herculean efforts of someone like Warren Stutt, who you'll hear from later today, to figure out that there was more unread data at the end of the raw binary file. He had to figure out how to decode the binary FDR file so he could recover the missing data. Once that was accomplished, we have data that matches the direction of motion precisely, but whose path was offset due to sensor drift. This had to be corrected by calibrating the FDR path to actual evidence on the ground. In other words, the actual position of the plane indicated in the FDR has systematic errors in it, so it creates a cumulative drift of the data that had to be corrected repeatedly during the flight because this is using inertial guidance, not GPS. However, the directional information was very precise. Approaching the Pentagon in alignment with the radar and FDR data, there's a series of impacts or observations that I will call points of contact, and these are consistent with the approach of a large plane. The first point of contact is a single frame of a security camera at the Citgo gas station that shows what is most likely the shadow of the plane as it passed by. The green image here is the plane, and here's the track, and in black with white outline beside it is the shadow of the plane as figured by the angle of the sun and the height of the plane and so forth. This blue object is the Citgo gas station, and one of the security cameras was looking in this direction, and it saw a shadow spot for one frame. Now, this is very fuzzy, difficult data, but it's there, and it's consistent. It's the shadows in the right place at the right time for one frame only, and so the most reasonable interpretation of this is it's the shadow of the plane. Now, in the path here, there is a bush or something in the foreground, this fuzzy white area, dividing this into two parts. But this is a single frame. I'm blinking back and forth between the frame that contains the shadow with the previous frame, so by contrast, you can see the shadow. And there's a section of Wayne Costy's PowerPoint video that discusses that. The next point of contact is a missing rung and a scar on a camera pole mounted by Highway 27. This is on the bridge just before you get to Highway 27. And this has long been seen as a maybe as far as a point of contact with the plane. But people said, well, we don't have the view just before there, so how do we know it wasn't a pre-existing condition? Well, in any case, you'll hear more about that in just a second. The next point of contact, actually two of them are essentially simultaneous. There's a tree here on the overpass. Here's the overpass right here. And there's a tree with a notch taken out of it. And here's a close-up of the notch. One of the things that was an unexplained phenomenon is the security camera footage looking at the plane crossing the lawn shows the right engine emitting a large smoke cloud. And that was a big distraction, but we'll come back and talk more about that later. It appears that the right engine had just prior to that scooped out the top of this tree. Now, if you were to take a mower blade, even if it were dull, like John Cole, who's a colleague of ours, he has a tractor and a mower, he mows brush on his property, and I had him calculate the speed of the tip of the blade. It's about 100 miles an hour, and that easily mows brush even when it's dull. What we have here is another dull blade, so to speak, the edge of the engine, and going at over 500 miles per hour, which would be 25 times the kinetic energy, because it goes by the square of the velocity. So it's a lot of energy, and so it's easily, in other words, it cuts through the brush before it has a chance to move out of the way. So it can act like a blade here. Almost simultaneously, there was a pole mounted right by the tree, the first light pole, and it was hit solidly by the wing and broken into 3 pieces. And these pieces are all accounted for by looking at the area right around where the pole stood. Now, here comes some physics lesson. Some people have asked, why is this pole debris right where it stood? Why isn't it kicked so far across the lawn because the plane was going so fast? The answer is the same reason that a bug is going to go squish on your windshield rather than getting knocked out of the way. It's a matter of the ratio of kinetic energy to momentum. So for instance, if If you take a slow-moving railroad car that's adrift on a track, and you get in the way, it can knock you down the track, and if you lose your balance, it can run over you. But if you take a bullet that has the same momentum, it's not going to push you, it's going to leave you where you stand and put a hole in you. So in other words, high kinetic energy from the bullet, because of its high speed, balances it in a different way than if you have low speed and high mass. Large mass, small velocity, a lot of momentum. Small mass, a lot of velocity, a lot of momentum. But in the second case, there's a lot of kinetic energy. And that's what does this kind of damage. So typically this would be hit, broken, and fall in place. The tall vertical section of the second light pole was not broken. It was bent about 90 degrees. It's down here on the side of the road, down here. And the fact that it was bent and not broken, it was knocked over, but it's an indicator that this was hit by the very tip of the wing, the left wing, and so it was skimmed. Had it been hit solidly, it would have been shattered, but it was just skimmed enough to push it down. Now that raises an interesting prospect. I mentioned a minute ago that the camera pole over here, this is the top view, right here is the tree. The white squares there are the light poles. Light pole 1, 2, 3, 4, 5. The first light pole got hit solidly by the wing. The camera pole right here was skimmed by the right wingtip, and the second light pole was skimmed by the left wingtip. And so if we calibrate the position of this path correctly, you can see we have a measurement of the wingspan of the plane. And I just did this within the last week, okay? So this is a new entry to this talk. Various people have estimated the actual path through here slightly differently based on where it hit the Pentagon. I realized touching these two poles is a more precise way to calibrate the exact position of the track. So the heavy red line here is sort of a standard view of where the plane was. But I constructed this arrangement on a graphics program where I could slide the whole thing back and forth and fit it to see how it would interact. And it turns out if I position this, so here's the wingspan of the plane, the white tips are the tips of the wings, these orange dots are the engines, and there's a white center dot, and these various lines indicate how they would move. If I touch the right wingtip to this pole, this one is touched automatically. So in other words, what I'm using here is the wingspan of a 757. And if I use the 757's wingspan, it exactly fits between the camera pole here, the second light pole here. So there we have a wingspan measurement. In principle, it's good to within inches. In practice, because of the fact of the positioning error of trying to do the measurements on a Google Earth map like this, we can at least say within a foot or so, we have the wingspan of a 757 indicated here. Back to the light poles. Here's the structure of the light poles. You have a vertical mast. You have two arms that reach out to support the lamp here at the end. Lloyd England's taxi came to rest next to the first light pole, but traveling at about 40 miles an hour, it would have taken a little over 160 feet to come to rest if you use reaction time and braking time in a standard calculation. So to come to rest by the first light pole means he was not hit by any part of the first light pole. He was hit in the windshield 160 feet or more further north on the road. Now, if you look further north on the road, that distance puts him beside the second light pole. And if you examine the debris from the second light pole, we already saw that the mast is off to the side, and the upper support arm is shown, and here's the lamp, but there's no sign of the lower support arm. The lower support arm, however, can be identified by elimination. All the parts of the first light pole can be identified here, leaving one extra. And right here beside the taxi is what appears to be the lower support arm from the second light pole. So this accounts for the damage. He was he was hit by the support arm from the lower support arm from the second light pole. That pierced his windshield, and he came to rest here. There's been a lot of discussion of how it was impossible for this long, 30-foot length down here. It was so heavy, 200 pounds and all that. They made a big deal about how Lloyd England supposedly identified this as what hit his car. Well, I don't think he did identify this, and it doesn't appear that he did in the videos. However, even if he did, he's just wrong. He is in error because we know he could not have been hit by any part of the first light pole. He was hit by a part of the second light pole, which is smaller, and it gets rid of all the ambiguity on how that event occurred. There are 3 more light poles here. I'm just going to step through them and continue on. If you want to look at the details of each of these, that's in Wayne Costy's video series. If you go to 911speakout.org and look at the Wayne Costy tab, you can get the whole video. You can also get the 35-minute summary that we saw earlier today. The next observation is the plane flying across the lawn, as seen by 2 security cameras that are by the driveway, the entrance to the Pentagon. I'll come back to this at the end of my talk. However, several objections have been raised to the plane crossing the lawn and impacting the Pentagon. I'd like to deal with those as we go. First, some say the plane could not fly that fast at sea level. It was clearly flying faster than recommended speed, but not so fast that it would break up. Note that it was in a dive. It was coming down, and it was pulling out of a dive, and that would help it maintain higher speed. And also notice that the highest speed, around 560 miles an hour, is what's indicated in the FDR. And that was only the speed in the last few seconds. It was picking up speed all the way into the Pentagon. I also want to point out that if you look at, there's an analysis of the plane that hit the South Tower at the World Trade Center, Flight 175, and that one was also in a dive. That one was also at sea level, and its speed was measured to be about the same as what we're talking about here. So whether or not you have theoretical objections to that speed, we have multiple examples where it appears observationally that was the kind of a speed it was traveling. A second objection to the plane crossing the lawn is put out by Pilots for 9/11 Truth in a video that they have on their website, which claims that since it was in a dive and they did a calculation long ago, that it was in the process of pulling out of the dive so it doesn't hit the lawn, flattening it out to where it would go in the Pentagon, it would have to take, take like over 10 Gs of pull-up in order to flatten its path out. Frank Legg, many years ago, 5 years ago or more, pointed out the error in their calculation. They didn't respond. A couple years later, I decided to do my own independent calculation. Mine agreed with Frank's, and they didn't respond to me either. Wayne has now done another calculation, and the FDR itself has the actual G-force calculation, not a calculation, but direct measurement of what the actual G-forces were, and they're nowhere near 10. They're all in a very feasible range. The third objection to a plane flying low over the Pentagon lawn is ground effect. And ground effect is what you might experience when you come in for a landing and there's a little cushioning just before the wheels touch the ground. But you're at a slow speed and you're dealing with the vortices that come off the wings as they interact with the ground. And the problem is this effect diminishes with increased speed. So the reason that ground effect is noticeable when you land is you're going very slow, very close to the stall speed for the plane. If you were coming in at 500 miles an hour, there would be virtually no ground effect to consider. And the other thing is, even if there is ground effect, just a slight adjustment on the tip of the plane would cancel it. So this is not really a valid objection. Just before the plane hit the Pentagon, it encountered a couple more obstacles. One was this blue thing here is the generator trailer, It was a large diesel generator used during the refurbishment project. This is an illustration of the kind of generator it was, and typically these are in the range from 20 to 40 tons. And so this was sitting out, this is not the same one. This one was sitting out in front of the Pentagon. Here it shows it after it was hit. Notice a major chunk was taken out of it. That was by the right engine of the plane. There's also a groove that goes across the top here. Get that right here. And it turns out the measurement from the engine impact to this groove matches. There's what's called a canoe that's right under the wing, and so that indicates that was carved out at the same time. When it hit the generator trailer, it tended to give a little bit of rotation to the plane. It also tended to tip, it tended to make the plane roll a bit. The left wing went down, and it turns out that the engine then impacted this little structure here. So that's a retaining wall. I'm not quite sure. It's some kind of a subterranean thing, but there's a little wall around it, and that's what it hit. And here's a picture of it. Here's that concrete retaining wall, and here's the chunk. So it's right at ground level. So yeah, the engine did touch the ground essentially at that one point. Now, here's the dimensions of a 757. And notice the dimensions from the engine to engine is a little over 42 feet, 42 and a half feet. This matches the distance between the generator scar and the retaining wall scar. So this has been known for a long time. If you come back to this diagram from earlier, when I measured I basically calibrated the flight path to where it took into account touching the camera pole and this light pole. Automatically, well, look what happens. This orange or yellow line here, this is the generator right here. It goes right across it at the right end of that generator trailer, and the other yellow line goes right across this spot right here, which is where that retaining wall is. So by calibrating the path, taking the FDR path for the direction and positioning it so that this one point touches the camera pole, I forgot to mention, that also puts the right engine passing directly through the tree where you saw the notch taken out. So we have the camera pole, the tree, the left wingtip touching the second light pole, the right engine hitting the generator trailer, and the left engine hitting the retaining wall. So all 5 points of contact line up perfectly on this calibration. This is 1 week old. I just did this. So here it shows those final points. I'm going to leave these. Wayne is going to talk about these, the generator trailer, the retaining wall, and this tree, because the tree in particular figures heavily into what happened immediately following as the damage was done to the Pentagon. Now, I'm going to finish my part of the presentation. I think it's easier to do it with a little video clip here because it involves some video footage here. So this is seeing the Pentagon plane.
In March 2002, 5 frames of a video from a security camera at the Pentagon were released or possibly leaked as small BMP images. The first of those frames purportedly showed the Pentagon plane. The remaining frames showed the growing fireball. Whatever was crossing the Pentagon lawn was in the distant background of a wide-angle shot and mostly hidden by a foreground obstruction, a post that, as it turned out, housed a second identical security camera. The most obvious feature of whatever was crossing the lawn was a white smoke trail that was hard to interpret. If there was a plane, why was there a smoke trail? Planes don't emit smoky exhaust. Missiles do. Also, how could a large plane, such as a 757, hide behind the small post in the foreground? The tail of the plane was visible, but without more context, it was difficult to identify it as the tail of a large plane. This image fueled speculation that the actual impacting object was a small plane or a missile. Compounding the confusion, the picture had an erroneous timestamp, added later during copying of the file, it turned out. It was not in the original. The lack of context and the small image size did more to sow confusion than shed light on what hit the Pentagon. Some have speculated that sowing confusion might have been the intention. Two longer videos shot at 1 frame per second from the same camera and a second camera mounted in the foreground post were released in 2006 in response to a Freedom of Information Act request for surveillance videos that may have captured the incoming plane at or near the Pentagon on 9/11. One of these included the original 5 frames. Many people viewing these as still frames over the years, myself included, failed to see the plane. The lack of a clear visual image of the plane stirred speculation about what, if anything, actually hit the Pentagon. By the time the 2 longer videos were released in 2006, no plane at the Pentagon speculation was well established to the point that this belief was virtually synonymous with the 9/11 truth movement in many people's minds. There is a technique used in astronomy for seeing details in cluttered photographs. Imagine a star field photographed with a telescope, then photographed again the next day or several days later. How could you tell if one of those tiny dots was actually a distant undiscovered planet? Unlike the stars that remain fixed, a distant planet would move. The problem is how to recognize the motion of a tiny dot in a cluttered field. Or what if you were looking for stars that vary in brightness? This is something astronomers study. But how do you go about finding the variable stars? Here are simulations of 2 photographs of the same star field taken a few days apart. The problem is to find if anything has moved or changed in brightness. One technique astronomers developed long ago is to use a device called a blink comparator. It allows you to alternate the view back and forth between 2 photographs. Let's try it. Do you see the planet moving? Do you see the variable star? You probably were able to see them immediately. Your eyes are attuned to noticing changes, so what changes stands out. This technique, by the way, was how Pluto was discovered by Clyde Tombaugh back in 1930. The image of the Pentagon plane is similar to the astronomical problem, in the sense that we are looking for something against a cluttered background, and we don't know exactly what to look for. Ken Jenkins showed me that the blink technique is useful for seeing the Pentagon plane. He was using animated GIFs. GIF images have limited color resolution, so I implemented a JavaScript routine to blink full-resolution images on my website. But the same thing can be accomplished as a rapid-fire slideshow recorded as a standard video. Take a little time and examine the blinked images. Here's a zoomed-in view. What we see is fuzzy because we're enlarging a tiny pixelated image. I think you can see there is something that actually looks like the fuselage of a plane to the left of the smoke cloud. You can see the tail sticking up to the skyline. Notice the purple stripe over a white area. American Airlines planes have red, white, and blue stripes running down the side. In the original picture, the airplane image was tiny, so the width of the stripe was a single pixel. The purple stripe may be a combination of the color information in the red, white, and blue stripes. It has also been suggested that the bluish color is the reflection of the sky by the reflective top half of the fuselage. Now let's do the same for the frames from the other camera. Here the most obvious feature is the tail sticking up to the sky. You can also barely see the purple coloration across the top of the foreground obstruction, and barely distinguish the nose of the plane to the left of the obstruction. Here's another blink comparison using 1 frame from each camera, showing the movement of the plane in the time interval between the 2 exposures. Note that the plane is both crossing our field of view and coming toward us, so the size changes. Also, the 2 cameras have slightly different points of view, so it's harder to perfectly align all the fixed features, such as the trees in the background. Notice the details in the smoke trail. The undulations along the bottom edge of the short smoke trail can be seen in the longer smoke trail as well. The longer smoke trail is an extension of the trail that's already there. Notice how far the plane has moved in the time interval between the 2 exposures. The 2 cameras were recorded on the same recording device, so they were not simultaneous exposures. The film, The New Pearl Harbor, assumes without justification that the offset time between the 2 videos was 1/30th of a second. There's a pickup truck owned by Mickey Bell, one of the workers in the Pentagon refurbishment project, that is visible after the fireball. Wayne Costi has determined, based on measurements of the movement of the truck, that the time delay from one camera to the other was actually 4/30ths of a second. He did this by comparing how far the truck moved between two frames of the same camera, which is a 1-second interval, with the distance it moved in the offset time between the two cameras. Notice that the plane moves a little less than its own length in that time. Based on the length of a 757-200, Wayne estimates that the distance moved was about 106 feet. So the speed works out to be 542 miles per hour, which is in the ballpark with other measurements of the speed of the plane. But this measurement is independent of any other speed measurements. One issue that may bother you a little is how stubby the plane looks in these images. A 757 is long and slender. The plane is coming toward us at an angle, but it still doesn't look quite right. The plane is distorted because, as we can see looking at the wider picture, the whole view is distorted by the wide-angle camera lens. Note how the roofline of the Pentagon is curved outward. This is called barrel distortion. A number of image processing programs, like Photoshop, have the ability to correct for this distortion. I'm using an alternative program called GIMP. GIMP provides a slider to balance barrel distortion with the opposite effect, which is called pincushion distortion. Simply adjust the slider until lines that are supposed to be straight are shown to be straight. The result is the borders of the image are given severe pincushion distortion, but the image itself is flattened. This correction stretches out objects near the edge of the field, which were compressed in the original distorted view, so the plane looks more elongated. It's starting to actually look like a 757. Another question that may be lingering in your mind is, why is there a smoke trail? A number of explanations have been suggested. The right engine of the plane had moments before gouged the top of a tree on the overpass near the first light pole, leaving a circular gouge in the foliage with stripped stems remaining. The smoke we are seeing can be explained as the burning foliage in the right engine on the far side of the plane, which is what hit the tree. If we return to the image of the plane in the original 5 frames leaked out in early 2002, now that we know exactly what to look for, we can see that the original frames are identical to the corresponding frames in the longer version released several years later. There's no sign of tampering. If any tampering happened, it had to have happened immediately after 9/11. If they were trying to sell the public on the presence of a plane that wasn't really there, they did a bad job of it. The smoke trail was not a selling point. It was a huge counterpoint to their message. The extreme subtlety of the plane image against the cluttered background, requiring special techniques to even see it, is not what one would expect of a propaganda piece. Also, as we've seen, there was complex interrelated information in the images, such as the motion of Mickey Bell's truck correctly corresponding to the speed of the plane, and the distortion of the plane image that was removed when the overall camera distortion was corrected. These self-consistent elements argue for the authenticity of the images. The bottom line is we have good reason to believe that we are actually seeing a large, fast-moving plane approaching and impacting the Pentagon on 9/11.